Hello guys, welcome to Maker Mindset. In this new series, we are going to talk about bed leveling an Ender 3 printer and your first print. So, let's begin. First, we need to go over a quick introduction on bed leveling. Well, for starters, we are not going to need a carpenter's level in order to do this type of bed leveling. The bed leveling that I'm talking about is a type of calibration that you will need to perform as soon as you finish assembling your printer and before you are able to print anything. You will also need to do this calibration later on if your printing jobs are failing because the objects that you are printing are not sticking to the print surface. On the Ender 3 and similar 3D printers, bed leveling is accomplished by adjusting the 4 knobs that can be found underneath the build plate. When you turn those knobs, you compress the springs underneath the build plate and, as a result, alter the alignment of the build plate in relation to the print nozzle. During the printing process, the build plate will move back and forth in the y-axis, while the hot end will move left and right on the x-axis. That's why we need to perfectly adjust all 4 corners of the build plate. Now, the process to align the build plate in relation to the print nozzle is as follows. First, you need to bring the hot end to the left-hand side and push the build plate almost all the way to the back. The tip of the print nozzle should be more or less aligned with the center of the knob that you will be adjusting. With the aid of a post-it or a sheet of paper from your inkjet printer, we will be gauging the distance between the print nozzle and the build plate. Now, you might ask, why use a post-it? And the answer is pretty simple. This type of paper has a standard thickness of 0.1 mm, and that's the exact required measurement here. So you put this piece of paper in between the hot end and the build plate, and adjust the knob underneath it until you feel the nozzle brushing against the piece of paper. When you're done, move the print nozzle to the right until it is more or less aligned with the next spring. Here you follow the same procedure. You put a piece of paper between the print nozzle and the build plate and adjust the knob underneath it until you feel the print nozzle brushing against the piece of paper. When you're done here, you will need to pull the build plate to the front until the next spring is more or less underneath the print nozzle. And here again, you follow the same procedure with the piece of paper and the knob underneath it. Finally, when you're done here, you push the print nozzle to the left-hand side until it is more or less aligned with the last spring. And one last time, you use a piece of paper to gauge the distance between the print head and the build plate while adjusting the knob underneath it. And we are done, right? Not quite. And the reason for that is a phenomenon that we need to be mindful of when doing bed leveling. So let me show you. Every time you adjust one of the knobs, the adjacent springs act as a fulcrum point, causing the opposite spring to have its adjustment altered. Obviously, the same phenomenon also happens on the opposite diagonal, where when you adjust the knob on that side, the adjacent springs act as a fulcrum point for that diagonal, and the adjustment for the opposite spring is also altered. This problem is especially evident when you're doing bed leveling for the first time on your brand new printer. To remedy this situation, you will need to do several rounds of the adjustment of all the knobs until you come to a point where the knobs no longer need adjustment. When you are done with the adjustment of the knobs, you should bring the print nozzle into the center of the build plate. What we are doing here is making sure that our build plate is not warped. Normally, you should not be worried about this problem. It's pretty rare, but if you are one of the unlucky ones that got a warped build plate, no amount of bed leveling will help you solve your issues of first layer adhesion. In this case, you will have basically 3 solutions to this problem. Solution number 1, spending $20 and buying a glass bed from Creality. The second solution would be to do an automatic bed leveling upgrade to your printer, like with the BLTouch upgrade kit, for example. With this pretty expensive upgrade, you'll be able to create a topographic map of your entire print surface. With that, your printer you'll be able to raise or lower the print nozzle depending on the area of the print surface it is printing. And solution number 3, which is a software solution. In this case, you will need to update the firmware on your Ender 3 printer in order to enable the mesh bed leveling feature. With mesh bed leveling, you will be able to create the same topographic map that is created by the second solution, but you will have to do it manually. This is not a perfect solution and it's much more time consuming, but at least it's cheaper than the other 2 solutions, right? If you guys want me to make a video on mesh bed leveling, write down your request on the comment section. Once you have adjusted all 4 knobs in an acceptable way, you will need to do a short test print in order to fine-tune your adjustments. And here's what you need to be paying attention to when examining your first test print. If, for example, you set your build plate too far from the print nozzle, the filament is not going to be properly squished against the print surface. And as a result, you will see gaps in between the filament lines when looking from the top. When you look at the printout from a profile, the filament will look pretty rounded. Now imagine that you set your build plate too close to the print nozzle. In this case, you may see areas of the printing where the filament was not even able to come out of the print nozzle. You may even hear clickings from the extruder as it unsuccessfully tries to push filament through the nozzle. And the printing, when seen from a profile, will feature ridges in between the filament lines that can be easily noticed when you rub your finger against the surface of the printout. You will realize that you've got the Goldilocks distance between the print nozzle and the print surface when your printout has no gaps in between the filament lines, and when seen from a profile, the filament lines merge with one another, forming a smooth surface. Now, enough of theory. Let's put our recently acquired knowledge into practice. Yay! It's time to lower the Z-axis stop switch? Okay, I lied. We're not gonna do bed leveling yet.
Oh, come on!
But I have a good reason for this. I know that this series was intended to explain how to do bed leveling on the Ender 3 and similar printers. However, the printer that we are using to help illustrate this process is an Ender 3 Pro. One of the coolest characteristics of this printer is that it features a flexible magnetic print surface. Sadly, Creality didn't take into account that this print surface is much thinner than glass beds featured in previous versions. So, when you go to the menu and set the printer to home, the Z-axis stop switch ends up stopping the print nozzle a little too high. If you try to go through the bed leveling procedure with the stop switch set this high, the springs underneath the build plate will end up being too loose, and as a result, the build plate will go out of level at the slightest disturbance. To resolve this problem with the Ender 3 Pro, we need to lower the Z-axis stop switch. To accomplish that, we need to, first, tighten all 4 knobs underneath the build plate. We need to tighten them all the way. Now pick up your caliper, set it to millimeters, and adjust it to 1 millimeter. Now tighten the screw on top to keep the caliper at the set position. Pick up a post-it and stick it to the caliper like so. Get a pen and mark the 1 millimeter measurement on the post-it. Now pick up the open-end wrench that came with the printer and stick the post-it like this to the largest side of the wrench. The part of the post-it that will be sticking out should be 1 millimeter wide. Trim out the rest of the post-it and we will have our measuring tool. Now pull the bed to the front very slowly. We will use this measuring tool to determine how much of the screw will be sticking out from underneath of each of the 4 knobs. You should go underneath each knob, patiently doing this measurement in the front and on the back. Again, whenever you're pulling the bed, do it slowly. Now manually lower the gantry. And push the print head until it is more or less aligned with the front knob on the left. As you can see, after lowering the gantry all the way to the bottom, there is still a big gap in between the print nozzle and the build plate. The next step is to remove the Z-axis stop switch. Remember, those screws feature T-nuts, so you don't have to unscrew them all the way. Don't forget to unplug the electrical cable. You see this notch? It needs to be removed so that we can mount the Z-axis stop switch in a lower position. Now you can tighten the screws, but very lightly at the moment. Now pick up an old credit card. I'm sure you have many laying around. Then lower the print head until the nozzle lightly touches the credit card. Now you are supposed to lift up the Z-axis stop switch until you hear a click. Don't lift it all the way. You should stop the switch as soon as you hear the click. This is the perfect spot for the switch. Now, being careful to maintain the switch at the same position, we should tighten the screws. No need to go crazy here, but you should tighten the screws pretty well. Don't forget to plug back the electrical cable. Now we are done. Next week, I promise, we will do bed leveling. That's it for now, but there is more next week. Okay, I just published this video and now it's your turn. Go down in the comment section and drop a little note. I love to read your feedbacks, your suggestions, and some of you made a couple of corrections that were very helpful. If you want to support the channel, now we have a Patreon account. The link is in the description. And don't forget to leave your likes. They are very important for the channel. And I want to ask you a favor. Please, please, please don't forget to subscribe. This channel cannot be monetized until it reaches 1,000 subscribers. Here's the registration button. If you want to watch the rest of this series, you can click on this link here on the top, and at the bottom you have a video that the YouTube algorithm thinks will be the best fit for you. So, bye bye now.